Alright, we're going to start today the Quadratics Unit 6 again. This is day 5 of the unit. We've done several things over the course of this unit, and the last thing we did was talk about graphing things from standard form, vertex form, and root form. And we're going to talk about a lot of that again today. We're going to review it, and then we're going to go into writing the equation given a point and either the roots or the vertex, and sometimes a graph, and then being able to write the equation in standard or vertex or root form depending on what we're given. When we analyze, well, let's go first over our objectives for the course. We're going to, for the day. The objectives are we're going to be able to analyze the graph of a quadratic function, write an equation for a quadratic function given its roots and a point on the graph, and write an equation for a quadratic function given its vertex and a point on the graph. Our key vocabulary is going to stay pretty much the same. We're looking at remembering what the domain is, which is all the x values, the range, the y values, the difference between a relation and a function. Remember, all functions are relations, but not all relations are functions. The different forms of a quadratic, standard form, root form, and vertex form. The vertex is the low point or the high point, the coordinates for that point on a quadratic. And the maximum and minimum points are the y values of that low and high point. So when we talk about analyzing a graph of a quadratic, we're going to find, in addition to graphing it, we're going to find its vertex, its axis of symmetry, its maximum or minimum value, its domain, range, and its roots. So we find out pretty much everything there is to know about any given quadratic function, and we can do that from any of these forms, but specifically, we can read the roots out of the root form, the vertex out of vertex form, and so we're going to go through the various forms and how to find these things if we're starting with that form of the quadratic. So this first example we have, if you remember, this is standard form. So let's go ahead and go through this and make some notes. So this is the standard form of a quadratic. And remember, standard form, the generic formula is y equals ax squared plus bx plus c. And so in this particular example, a is 1, because if there's nothing written in front of the x squared, it's a 1. B is 4. And remember, this is a, b, and c. And so c is 3. So there's a few things we need to remember about what we know from standard form. First of all, we know how to find the vertex from standard form. And the vertex is called HK. So I'm going to write that over here. Remember, that's H. K is how we notate it in our formulas. H is the x value. And so H, the x value of the vertex, is equal to negative b over 2a, and we remember that hopefully from last time. And so using the numbers that we just discovered out of our equation, b is 4, so we have negative 4 over 2 times a is 1, which will be negative 4 over 2 or negative 2. So that's the x value of our vertex. So we can start that and put here. Now the axis of symmetry is the vertical line that goes right through the vertex. So it's got its equation is x equals, because it's a line, a vertical line, it's always x equals. And it's going to be, in this case, 2. The equation of the axis of symmetry is always going to be x equals whatever your h value is. Okay? So we could go ahead and draw that on here. We usually draw it as kind of a dotted line or a dashed line. So we could go here at, excuse me, it's -2. I wrote it up there but didn't write it here. Okay, it's -2. Okay. So, and let me erase that so it's better, written better. Okay. That's equals -2. So we're going to go on and now finish what I started here. We're going to put dashes all the way through this graph on x equals -2. So that is the axis of symmetry. And again, the axis of symmetry is a line. Now, we have to figure out what the y value is. So anytime we want to figure out a y value, we plug it in. We can put our point here as -2. And then we just plug it into the form. So I'm going to go down here. And I'm going to use x squared plus 4x plus 3. So I'm going to have -2 squared plus 4 times -2 plus 3. And so that's going to be 4 minus 8 plus 3. So that's +7 minus 8 will be -1. So all that combines to be -1. So my vertex then is at 2, -1. So I'm going to plot the point here at 2, -1. Put a point on the graph. And now I'm going to have to figure out some other points. So we pick x's and we decide what we're going to use. Well, what you want to decide to use are easy ones. Go to the left and to the right of the vertex. So I could go -1 and 0. Those are the 2 points to the right of the vertex. And I could go -3 and -4. Well, 0, one thing we know, this is the other thing we know about something given in standard form, is that the y-intercept is 0c. So in this particular example, it's 0, 3, because our c value is 3. So I know I have a point at 0, 3 just from the equation, the original standard form. So I can go up and put on my graph 0, 1, 2, 3 and put a point right here at 0, 3. Now because that's an axis of symmetry, and if I have 2 spaces to the right of the axis I have a point, then 2 spaces to the left I have a mirror image point. So I also know that there's a point at -4, 3. Okay, so I can go ahead and put that in the table, and you need to fill in the table. If there's a table there, you need to fill it in. So now we're going to have to figure out these other 2 points. So I'm going to use the -1, and I'm going to put it in the equation, which is x squared, so it's -1 squared plus 4x, so that's plus 4 times -1 plus 3. So that's +1 minus 4 plus 3. And so that's going to be 3 plus 1 is 4. 4 minus 4 is 0. So all that adds up to be 0. So I have a point at -1, 0. And again, because this is an axis of symmetry, I have a mirror image point over here at -3, 0. Okay. So now you can sketch in your graph. Okay. And let's decide the rest of these things that we have to analyze. The maximum or minimum value, because it opens up, it has a minimum. And the minimum is the y value of the vertex. So the y value of the vertex is -1. So that is the minimum value of this quadratic. The domain, all quadratics have the same domain. It is -infinity to +infinity. There's sometimes you think you can never say all, but in this case, all quadratics have the same domain. The range, since it opens up, it starts at the bottom and goes to infinity. The bottom number is -1, so the bottom number of the range includes -1, and it goes to infinity, and there's always a curved bracket on infinity, because you never get to infinity. And we can see that -1 is included as a point on the quadratic graph. So we have the square bracket on the -1. The roots, we've already said, they're here where it crosses the x-axis. They are at -3 and -1, or you could say -3, 0, -1, 0. That's the roots or the x-intercepts of the quadratic. And so now we've done everything, we've found out everything, we filled in a table, we've graphed it, and that's what you do with standard form. You know the vertex, the x value of the vertex pretty easily, you know the y-intercept pretty easily. Once you have the x value of the vertex, you know the axis of symmetry. Once you figure out the y value of the vertex, you can figure out your minimum or maximum, and from that you know the range, the domain always is the same, and you may have to graph a few points to figure out where the roots are. Okay, so that is how to analyze a quadratic equation if it's given to you in standard form. Now let's look at our next slide, which this is vertex form or translation form. Sometimes it's called either way, but I usually call it vertex form because we can read the vertex right out of the equation. And remember, if you have the parentheses squared, you know it's going to be vertex form. Now the basic vertex form is y equals a times x minus h squared plus k. Well, we see an a and an x minus h squared, but we don't see a k, so that must mean our k is plus 0. So now when we read the vertex, remember it feels like we're changing the sign on the x, so it's positive 2 and then k is 0. So that's our vertex. From vertex form we get the vertex. Now the axis of symmetry, x equals the x value of the vertex, so x equals 2. And it has to be x equals. You cannot just put a 2. Now looking at the 3 there, if a is positive, remember it opens up. So because a is positive, the graph opens up. So this quick sketch is that it will look like this. And so we have a minimum point. Our vertex is a minimum. So we have a minimum value, and the y value of the vertex is 0. So the 0 is your minimum value. Okay. Now let's start thinking about our graph. We know we have a point at 2, 0. So we're going to plot that on the graph. Okay. Now that's where it touches the x-axis, so that's also a root. So our root is at 2. In this case, the root and the vertex are the same point. Now there's only one root because it just touches and turns back. It doesn't cross it in two places. So this is really, this is a double root. When it's just a touch like that, it's a double root. It would really be a 2 and a 2 as far as the factoring of a quadratic. The factors would be identical. So at the point, if you wanted to list it as a point, it is 2, 0 as a point. Okay. So we know it opens up. We know we have a minimum value. Let's find some other points. So the easiest way is go, like I said, to the left a couple places and to the right. So we're going to go 1 and 0. That'll be the 2 points to the left. And then 3 and 4 will be 2 points to the right. Let's draw in our axis of symmetry, which again you just draw kind of a dashed line right through the vertex. That's our axis of symmetry. So we can locate more easily the mirror image points. So let's look at 1. And so we're going to put 1 into our equation and find that y value for it. So we have 3 times 1 minus 2 squared, and I don't need to put the plus 0. So 1 minus 2 is negative 1. So we're going to have 3 times negative 1 squared, or 3 times positive 1. So the y value for the 1 will be at 3. So at 1, we're going to go 1, 2, 3. That means our mirror image point at x equals 3 will also be 3. Okay. Now let me erase this, and we will work on the next point. So we're going to use the 0. So we have 3 times 0 minus 2 squared, which will be 3. 0 minus 2 is negative 2 squared, which is 3 times 4. Negative 2 times negative 2 is positive 4. So the point, that y value at 0 will be a 12. And so when I go up here, I'm going to have to go above because this only goes to 10. 4, 5, 6, 7, 8, 9, 10. So we're going to go up here to 12 or get close. Okay. And then we're going to have a mirror image point at 4. And so we can sketch our quadratic. Now, with that 3 there, it gets, I didn't draw my mirror point here. With that 3 there, it's pretty tall and skinny. The bigger the number in front, the bigger that A, the narrower and taller the quadratic gets. So I'm going to go ahead and finish filling out the table and put a 12 here, since I know I've got that point on the other side, the matching point on the other side of the axis. Now the domain again, negative infinity to positive infinity, all real numbers. And the range starts at 0, so you put the square bracket in 0. It goes up to infinity because it keeps going on since there's arrows, and a curved bracket always on infinity. So that's an example of how to graph from vertex form. You find the vertex, find the axis of symmetry, the minimum and maximum value, and then find some roots, plot some points. Alright, so now lastly we're going to go to root form. And if you remember, root form, the formula, I'm going to write it on here, is y equals a x minus root 1 and x minus root 2. And sometimes, again, if it's just a touch, the x and the root 1 and root 2 can be the same number. So what we read out of root form is, of course, roots. So we've got an x minus 2 and x plus 2. So you change the signs coming out of the roots. It's the value of x that makes that equal 0. So our roots are positive 2 and negative 2, or 2, 0, and negative 2, 0. Those are the two roots. So we're going to put those on the graph. Now remember, the vertex is exactly halfway between the roots. So in this case, halfway between the roots is 0. So x equals 0 is going to be the x value of the vertex. Now remember, I can do, for root form, h is equal to root 1 plus root 2 divided by 2, which in our case, in this example, will be 2 plus negative 2 divided by 2, or 0 divided by 2, or 0. Now, it's not always going to be 0, but it is in this example. So then I'm going to have to plot my point for x equals 0 for the vertex. I know I have points at 2, 0, and negative 2, 0. I can put those on the chart. So what is the y value for x is 0? Well, I have to put it in my formula. I've got negative 2 times 0 minus 2 times 0 plus 2, or negative 2 times negative 2 times positive 2, which is 8. So 0, 8 is my vertex. Okay. So I'm going to plot that here on the graph. So the axis of symmetry then is x equals 0, which turns out to be, in this case, the y-axis. So it's not going to show up very much when I mark my dashed line there. Now, does this have a minimum or a maximum? Let's look at our number in front of everything. We have a negative 2. So in this case, a is negative. So that means it opens downward or down. So my quadratic sketch just looks like this, which means it's got a maximum value. So I'm going to circle max, and the value of the vertex, the y value of the vertex, is 8. So that should be the highest point on this graph. So we know 3 points. We need to get 2 more. So I'm going to look for points one away from the vertex, which is at 1 and negative 1. So let me erase so I have room to calculate that. Erase all of this. And I kind of marked out my 8, so I'll put that back. And that's a 0. Okay. So let's just do, we'll do 1. And we put it into our equation. We have negative 2, 1 minus 2, 1 plus 2. So that's negative 2 times negative 1 times 3, or positive 6. Okay. So at 1, I'm at 6, and then I have a mirror image point. So at positive 1, I'm here at 6, and you have the mirror image point. If I have a point 1 to the right of the axis, I have a mirror image point 1 to the left. So I also have negative 1, 6. And then you can sketch your quadratic, and we see it opens down. If you're not sure whether it opens down, up and down when you plot your points, you'll figure it out. And what is the domain for every single quadratic? It is negative infinity to positive infinity. And this one is different. We have to be careful with the range because the range, remember, always starts with the lowest number. So we're going to go negative infinity up to the highest number, which is 8, and 8 will have a square bracket. Negative infinity will always have a curved bracket. Okay, so that is evaluating or analyzing a quadratic if we start with root form. So we've done all three. We've done standard form, root form, and vertex form. So we're going to then now go on to writing the equation of the line given some points on the graph in either roots or a vertex. Okay. So we're going to write the equation, and we have to know these forms. We have to know the vertex form and the root form and standard form. We're really going to use the first two for this exercise, not the third one. So this is the type problem you're going to see. I've got 3 examples, I think, for each one of them. We're going to write the equation of the quadratic with roots at 4, negative 1, and f of 0 equals 8. So if it gives us roots, we know where to use root form. So I'm going to write it here. We have y equals a times x minus root 1 times x minus root 2. So let's put it in root form. Y equals a. One root is at 4, so that'll be x minus 4. And one root is negative 1, so that's x minus a negative 1. So that's going to be x minus 4 times x plus 1. So when you put it in to the equation, it feels like you change the signs of those roots. Now I have to find out what a is. I can't have 3 variables. I can have x, y and plot it, but I can't have an a. So I have to figure out a. And with that, we're going to use this. This is an x, and this is y. This is f of x equals y. So I have an actual point, 0, 8, that I'm going to use for the x and y values. So I go back to the equation, and y was 8, so I say 8 equals a times 0 minus 4 times 0 plus 1. Now all I have is an a, so I can solve it. So 8 equals a times negative 4 times 1, or negative 4 times a. So when I divide by negative 4, a is equal to negative 2. So once I know a, then I put it back into that second equation that I wrote, and I say y equals negative 2 and then you put your roots in, and that's your final answer. That's your equation in root form for a quadratic that would go through those roots, or have those roots, and go through that point. Now, this is where we have a double root. So we've got an equation of a quadratic with a double root at 4. That means we've got y equals a, and we have x minus 4 times x minus 4. The roots are the same. You still have two roots. Okay? Once you set that up, then I'm going to use my point, -1, 5, to figure out a. So 5 is equal to a times -1 minus 4 times -1 minus 4. 5 then is equal to a times -5 times -5, or 5 is equal to positive 25a. So going over a little bit, dividing by 25, 5 over 25 equals a, and reduce that fraction, you have 1/5. So now that I know a, I can write the equation. I have y equals 1/5 x minus 4 times x minus 4. And if you want to, you can write it 1/5 times x minus 4 squared, because that's the same as x minus 4 times x minus 4. But either one of those would be a correct answer to this question. The last example for root form has a graph. So we have to read the roots from the graph. So let's look. If we have R1, if we have R1 and R2, okay, in this case, root 1 is equal to 1, 0, and root 2 is equal to 3, 0. And then my xy point up here is 0, -12. So let's first use our roots to put it in root form. So we have y equals a, x minus 1, x minus 3. Now to figure out what a is, we have -12 equals a, x minus, I have to put the 0 in for the x, 0 minus 1, 0 minus 3. So -12 is a times -1 times -3, or -12 equals positive 3a. So -12 divided by 3 is equal to a, which is equal to -4. Once we know a, y equals -4 x minus 1, x minus 3. Now if I write it x minus 3, x minus 1, that's fine. It doesn't matter what order you write those roots in, the factors in. Okay, so that is the equation of the quadratic in root form. We've done 3 examples of that, so hopefully that's enough for you to refer back to this if you need to, or refer back to your notes if you need to. Now let's go and look at vertex form. We've got 3 examples of that. So let's remind ourselves what vertex form looks like. So vertex form is y equals a times x minus h squared plus k. So 3 and 1 are h and k. And our point is -4, -13. That's what we're going to use for x and y when we want to figure out what a is. Okay. So y equals, let's first put the vertex in, a x minus 3 plus 1. Just put in h and k. Now I'm going to say -13 equals a times -4 minus 3 squared plus 1. So the first thing I have to do before I do anything is get the 1 moved over. So I'm going to subtract 1. And you end up with -14 equals a times -7 squared. Those ones had to be 0 when they go across. Okay, so -14 equals 49a. -7 times -7 is positive 49. So -14 divided by 49 will equal to a. When I divide each of those by 7, I get -2 over 7 for a. And now I just finished writing the equation. Y is equal to -2/7 x minus 3 squared. Be sure to put that in parentheses, quantity squared. And then I still have to have, I'm missing one thing, plus 1. That second line is the original formula without the a. Okay? So now looking at the bottom one, first let's write it in vertex form. We have y equals a times x minus a negative, or x plus 1 squared, and then -6 stays the same. So it feels like you changed the sign on the x, but the y stays the same. And my xy point that I'm going to use is 5, 6. So let's solve it for a. 6 equals a times 5 plus 1 squared. Now I'm going to add, and I still have the -6. So I want to add 6 to both sides. So you have 12 is equal to 6 squared. 5 plus 1 is 6. A. Okay. So now 12 divided by 36 will be equal to A, which is 1/3. Okay, get my pen. So that equals 1/3. So I have y equals 1/3 x plus 1 squared minus 6. Okay. Now we're on our last slide. And we have a graph. And we have the vertex. Now if you look here, it gives you your minimum. This gives you your minimum. Okay. And it gives you the vertex. So I have a point of 0, 1. And I have a point of -2, -2. And that's my HK. So I have y equals a times x minus a -2 squared minus 2. Or y equals a times x plus 2 squared minus 2. Now I'm going to use the point 0, 1. So 1 is equal to a 0 plus 2 squared minus 2. So when I add 2 across, you end up with 3 equals a times 2 squared. So 3 divided by 4 will equal to a. So in vertex form, we'll have y equals 3/4 x plus 2 squared, and then minus 2. Okay? And that's the final answer for that one, and that's the last example on the slide. Your homework is the back page of your packet, and so if you have any questions, be sure to see me either after school or sometime on campus, or Mr. Speck, if he is around, can help you, or Mr. Gomez or Ms. Lovell. They all know how to do this. Okay, thanks and good luck.